Okay, in Objective 2, we were looking at circles. Definition of a circle is the set of all points in a plane that are a distance r from a fixed point called the center, hk. That distance r is called the radius of the circle. And so you've had a little bit of experience with the parent equation of the circle with its center at 0, 0 and its radius of r. This is what that parent equation looked like, x squared plus y squared equals r squared. We are going to build on it, throwing in our idea of hk, which we've been looking at in a variety of contexts over this semester, with a translated center to hk. It's still going to be that idea of what zeroes out the x, that's my h, what zeroes out the y, that's my k, and then my radius will always be back here at the back. It's some number that's being squared within the context of my equation. The radius, though, will just be the number itself, the one that is being squared, not the squared number. Like if this was 4 squared, the radius isn't 16. The radius is 4. Right? And so you want to make sure you're keeping that in mind, especially once we get into graphing. Okay? We're going to do 3 here, though, just to kind of play with the equation, see what's involved with it. The first one is just making sure we are good with the general setup. The center is 2, negative 4 with a radius of 2 root 3. What would that equation look like? And so go ahead and take a moment, look at this equation, and think to yourself, okay, if my center was 2, negative 4, what would that mean this equation looked like here? Okay, well if 2 and negative 4 were my h and my k, meaning that's what zeroed out the x piece, that's what zeroed out the y piece, then within my equation, I would need whatever's in here to get zeroed by 2. What would get zeroed by 2? X minus 2. And then we have our plus. Same thing back here, I'd need my y to be zeroed by negative 4. Well, what would get zeroed by negative 4? Y plus 4. And then my radius at the back is 2 root 3 squared, which is 12 if you want to write it as 12, but it's also fine to write it as 2 root 3 quantity squared. It is not okay to write it like this, though. Okay, so if you think you're going to make this mistake, I'd maybe make this 12. Okay. Yeah. So here we go. Building on that a little bit, because obviously if the point and the radius are just provided, it's a fairly easy just kind of plug in. But what happens if we don't have all of those attributes? So number 2, we're going to explore that a little bit, some of the options you have. Okay, what if we've got are the end points of your diameter? How could we find, let's start with the center, how could we find that middle point between these two endpoints? The endpoints, remember, connect all the way across the circle, and I'm trying to find that center place. Think to yourself a moment here, how could I do that? Okay, well, within class, your classmates came up with 2 different strategies. The first was to just kind of draw it and count, in essence. Okay, and so I had students who went 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And so they were up here, and then they did negative 3 the other direction, and negative 11 down. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. And they plotted that there. And then they just kind of counted to the middle. They're like, well, okay, all the way across to get from negative 3 to 7 would be a distance of 10. So if I only counted 5 across, where would that land me? That would land me at 2. And they're like, okay, go all the way up. Negative 11 to positive 13 would be counting 24 up. What if I only went halfway? That would be 12 up. And so if I went 12 up from negative 11, that would put me at 1. And so they figured out that their midpoint was at 2, 1 by counting, which totally works. Now, obviously, if you don't end up at a nice point, that strategy might not be as pretty. But it does work. But then some others of your classmates remembered the midpoint formula, which technically speaking is what both were using. They're just, those who kind of went more the picture way are looking at it a little bit more conceptually. The midpoint formula, for those who use the midpoint formula, we're looking a little bit more analytically, a little bit more equation-based, which the midpoint formula, as a reminder, is x1 plus x2 divided by 2, y1 plus y2 divided by 2. And so then taking their x's and plugging it in, 7 plus negative 3 is 4, divided by 2 is 2, give me the x coordinate. Taking the y's and plugging it in, 13 plus negative 11 is 2, divided by 2 is 1, give me the y coordinate. And so you could find it that way. Okay? For the radius, that's the other thing we need to find. We found our center now, so I could put that into my equation. 2 needs to zero out the x. 1 needs to zero out the y. But we still need that radius. And so go ahead and take a moment and think again. What could we do with, what could we use to find the radius here? And again, there were several strategies put forward by your classmates. Some people looked at this as Pythagorean theorem. Some people did like a giant triangle for Pythagorean theorem to find the full distance of this diameter and then cut it in half for the radius. Others did like a little right triangle kind of here and did it this way. So this was 5 and 12, and so they figured out this was 13 using Pythagorean theorem. So this was 13 squared. Others used the distance formula, which technically comes from Pythagorean theorem, if you remember back to when you first learned distance formula. But if you like the distance formula, you could use it. That's the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So then you could plug your x1 and x2 in, your y1 and y2 in, and you would get 13 that way if you prefer that. Or the final strategy that we discussed is, well, like, I don't know, maybe you don't like Pythagorean theorem, maybe you don't like distance formula. We've got a general equation here, and we're trying to find that variable. Could I somehow get rid of these two to solve for r? And the conclusion was yes, because we've got 2 points. I could use either one of them, doesn't matter which one, and plug it in for x and y. X and y now are gone, and I could solve for r. And so we did that with 13 and 7, if I remember correctly. 13 minus 2 squared and 7 minus 1 squared, which gave me 11 squared, which is 121, plus, whoops, I plugged this in the wrong spot. Back up. Not 13. 13 is the y, not the x. So, learning from my mistake, make sure these get plugged into the right variable. So 7 here would get plugged into the x. 13 would get plugged into the y. 7 minus 2 is 5, squared is 25, and 13 minus 1 is 12, squared is 144. And so we get our r squared that way. R squared is 169. And so you could write your equation like so. Or you could write 169 as 13 squared if you were getting the 13 from the Pythagorean theorem or from the distance formula. All of them work. And so number 3 is actually going to be yours to kind of pause the video and work through it and practice it on your own. You can pick whatever strategy you want. They are all equally viable. It's finding which one you kind of have more of a preference for. Okay? So number 3 is going to be yours. Pause the video, give it a shot, restart it when you're ready. Okay? So here we go. Nice thing about this one, they did give us the center. So 3 needs to zero out the x, 1 needs to zero out the y. The question is, what's your r squared? Excuse me, sorry. So obviously I don't know what strategy you picked at home, because people picked different ones even in class. I myself typically do the plug-in when I solve this, so that would mean plugging the 5 in for the y and the 0 in for the x. Again, regardless of what way you pick, you should get the same answer. 0 minus 3 squared is 9, 5 minus 1 squared is 16, and so we get our r squared of 25. If you tried one of the other routes and didn't get an r squared of 25, or I should say an r of 5, if you wanted to write it this way, let me throw that up real quick. If you didn't get an r squared of 25 or an r of 5, maybe snap a picture of it, email it to me. I can really quickly help you figure out kind of where you got off a little bit. Because, again, no matter what strategy you use, you should get the same answer. Okay? Okay, so here we go. Let's play some with the equations. Let's go ahead and take a look at graphing then. Before we get into graphing, we do need to really quickly do a little bit more practice with complete the square. We did this in Objective 1. As I mentioned in Objective 1, we're going to continue to practice completing the square pretty much in every single lesson in some way, shape, or form, because it is one we need to make sure we've got under our belt. Okay? So I've got one for me, one for you. Okay, step 1, we need to separate everything that's not part of the squared variable family. So in this case, I actually have 2 squared variables, x squared and y squared. So I'm going to actually keep all the x's and the y's together. Meaning anything that's not an x or an y is going to get sent to the other side. I'm also going to reorder this so that my x's are together. So this is going to be x squared plus 2x, and then y squared plus 10y, but I'm going to subtract that 17 over to the other side. Okay, for completing the square, you're always looking at your middle term, asking yourself, okay, what would be half of that middle term? 1. What would be that number squared? 1 squared is 1. So I'm going to add 1 to this side, which means I also have to add 1 to the other. What's half of this number? 5 squared, 25. So add that number to the other side. So this piece here now factors to x plus 1 quantity squared. This piece here factors to y plus 5 quantity squared. And back here, negative 17 plus 1 plus 25 is 9. Or, for the sake of our graphing here, I'm actually going to rewrite that 9 as 3 squared. Because now we can see what our r is. Our r is 3 here. Okay? Okay, so the next one's yours. Pause the video, restart it when you're ready. Okay, so reordering, we have x squared and y squared, so I want all the x's and y's to stay together. There's nothing else, so we're good to go. So looking at this, we're asking ourselves, okay, do I need to complete the square on the x? Well, no, I don't have like a 2x like I did over here, or a negative 4x like my y does, or something along those lines. So this one's actually done. I'm not going to factor that one at all. There's nothing else. There are no other x values. The y, though, I do have to figure out something there. So in this case, I have to ask myself, okay, what's half of negative 4, negative 2, squared, positive 4. Okay, but in adding 4 to one side, I also have to add 4 to the other. And so I have x squared. This factors to y minus 2 quantity squared. And 0 plus 4 is 4, or 2 squared, for the purposes of the graphing we're about to do. Okay? Okay, so here we go. There are 3. Each are going to add in a slightly new element. It's not even new, it's a review element, actually back from units kind of 1 and 2 in that area. And part of the reason we're bringing those review elements back is because circles have 2 steps to them. Besides turning it into descriptive form, that is. Once it's in descriptive form, you're going to pull out your HK. So like for this one up here, my H would be -1, my K would be -5. And you're going to plot that. That's your center. And then you're going to count 3, because that's your radius, in all 4 directions, up, down, right, and left. And you're done. That's your circle. Like that's all that's involved. So in this case, my H would be 0, my K would be 2, and then I'd count 2 in every direction, and I'm done. So graphing is pretty quick for circles. So we need to throw in some inequality reminders to make sure we're continuing to remember kind of what's involved when there's an inequality at play. First one though is just to give us a chance to continue to practice. And so I know I haven't demonstrated graphing. I'm still going to challenge you to pause this video and see how far you get based off the explanation I've already given. This is to give you a chance to practice completing the square again, like what we just did 2 of up above. So try completing the square on your own. And then see if you can do what I just talked through up here. Can you identify what your HK would be? Can you plot that? And then can you count R in every direction for 4 more points on the edges of your circle? Okay, so pause the video, see how far you get, restart it either when you're stuck or you have an answer that you want to check. Okay, so here we go. Completing the square. X's and Y's both squared, so I'm going to keep them together. X squared and 10x. Y squared and 2y. 1 those an oddball. I'm going to subtract him to the other side. Okay, what's half of 10? 5. Squared. 25. Have to add that to the other side as well. Half of 2. 1. Squared. 1. And have to add that to the other side as well. And so this then factors to x plus 5 quantity squared plus y plus 1 quantity squared equals -1 plus 25 plus 1 is 25, or 5 squared. So in this case, my h would be -5. What zeroes out my x? My k would be -1. 2, 3, 4, 5, -1. And so that's the center of my circle. And my radius in this case is 5, so I'm going to count 5 in all 4 directions. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And you've got your circle. Okay, that's it. Okay, number 5 and 6. So number 5, I actually am going to walk through number 5, although if you feel like you're kind of getting it and you want to pause it and still make it your own, that's fine. But I kind of thought number 5 would be for me to demonstrate, make sure we're good with that inequality, and number 6 would be for you to try on your own. So with number 5, we still, inequalities don't change anything about the graphing initial steps. It changes a little bit about the very end. And so that's where we're going to kind of come back and review. But initially here, I'm still going to do complete the square. So we got x squared and -2x. We got y squared and 8y. Adding this 1 to the other side. Excuse me, I'm so sorry. Okay, half of -2 is -1. Squared is +1. Have to add that to the other side as well. Half of +8 is 4. Squared is 16. Okay. So this factors then to x minus 1 quantity squared and y plus 4 quantity squared. and then this is greater than 18, which we are going to rewrite as root 18 squared, because that is what the squared value would be, right? Root 18 squared would be the same thing as 18. My h in this case would be 1. My k would be -4. And my radius is root 18. So I'm going to start here at 1, -4. And then I'm going to count root 18 in every direction. Now, root 18 obviously is not a nice number, but I can do an approximation of it. Root 18 is pretty close to root 16. Root 16 is 4, but slightly more than root 16, so this is going to be slightly more than 4, maybe 4.2. Okay, and so I'm going to count 4.2-ish in every direction. 4.2-ish, 2, 3, 4.2-ish, 1, 2, 3, 4.2-ish, 1, 2, 3, 4.2-ish. Okay, here's where the inequality comes in. Back in units 1 and 2, we were looking at inequalities and looked at them in a bunch of different ways. But when it came to graphing, we reviewed what you would have learned back, I believe initially in Math 1 or Honors Math 8, I think is when it was first taught. Although it might have been earlier than that. But that idea of when you are graphing an inequality, you have to first look at the sign. And if your sign doesn't have an equals, what did that mean? It meant that this was a dashed line. If it had an equals, it was a solid line. Okay, and so that's the first thing we need to do, is to make sure that as I now connect this, that I make this a dashed line going around my circle here. What that's showing is that all the points that are on the circle actually wouldn't make this inequality true. Being on the circle means you're actually equal. Like that's why when we are equal, we do a solid line, because all those points that are on the circle are true for equals. Well, since we lack an equals here, we have to lack a solid line. Okay? The other thing that the inequality graph involves is one more thing. See if you can remember, what else did we do besides check our line? Okay, we also shaded. And inequality is shading. And so it's testing a point. And you could test whatever point you want as long as it wasn't on the circle. So maybe we test 2, 2, which is right up here. And if I plug 2, 2 into my equation, the question is that true or false? Or I should say my inequality, is that true or is that false? So in this case, if I plug 2, 2 in, I get 2 minus 1, which is 1, squared is 1. 2 plus 4 is 6, squared is 36. 1 plus 36 is 37. Is 37 greater than 18? Yes, it is. And so that tells me that all of this region out here where 2, 2 is located. 2, 2 is outside the circle, so everything else that is outside of the circle makes this statement true, and so it gets shaded. If I had tested a point inside the circle, say 1, -1, well, when you plug in 1, -1, you get a false statement. When you plug 1, -1 in, you get 0 plus 9, so 9 is greater than 18. Well, 9 is not greater than 18. So 1, -1 is false. And since 1, -1 is inside the circle, everything else inside the circle would be false. So I wouldn't shade that region. It's not true for my inequality. So you have to do that testing element when it comes to inequalities. From here on out, inequalities are now going to appear with all of your conics, including parabolas. On your homework, you will see your parabolas with an inequality. You still graph parabolas the same way, and nothing changes, just like nothing changed with our circle graph. But you have to check, is it a dashed line or a solid line, and where am I shading? Okay? So number 6, I want you to pause the video. I want you to give number 6 a shot on your own and restart it when you're ready. Okay, so number 6, we have x squared y squared minus 4y. Negative 12 is going to get added to the other side. Half of negative 4 is negative 2. Squared is positive 4. Have to add 4 to the other side as well. So now we have x squared, and this factors to y minus 2 quantity squared is less than or equal to 16, which is 4 squared. Okay, so that gives me my hk. My h is 0, my k is 2, my radius is 4, 0, 2, radius of 4, counting 4 in each direction. 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then this one, we do have an equals in our sign. So the fact that we have an equals tells me that this one is going to be solid. Okay, testing your point then, you do have to test a point somewhere. When I did this, I tested 0, 0, because that seemed like a nice friendly one to plug in, and it wasn't on my circle. Okay, so if I plugged 0, 0 in, I get 0 plus negative 2 squared, which is 4. 0 plus 4 is 4. Is 4 less than or equal to 16? Yes. And so wherever 0, 0 is, which in this case is inside the circle, that entire region gets shaded. Okay, and that's circles.